Hey guys, so last lesson in 5B, what we were doing is we were looking at how to use recurrence relations to model simple interest. Now we were doing it in such a way that it wasn't very efficient. It worked and it modeled it. However, if we had a scenario in an exam or a test or whatever, where we had to find the 50th term, we would have to add something 50 times, which is very inefficient. We need a quicker way to be able to work them out. Today's lesson, finding the nth term. Basically that means where we can find any term in a sequence without having to work out all the numbers before it. So if we were doing a simple interest problem where we had an $800 investment that was going up by $13, if we wanted to figure out the 25th payment, we would have to count up 25 times. That's going to take a very, very long time. It's not hard, it's just really tedious and annoying. So what we need is a much quicker and efficient way to work out terms without working out all the previous term, which is what we're going to go through today. Still going to be looking at it in the context of simple interest and unit cost and flat rate that we were looking at last lesson, but this is much more a quicker way. All right, so this is the formula we're going to be looking at. Vn equals V0 plus Nd. All right, it's all just letters. We need to actually interpret what this formula is telling us. So let's go through what each one of these letters actually means. Now V0, that one we should be very familiar with by now. That's the initial investment. D, we looked at D last lesson. We should hopefully remember that this was the formula. All right, where R is the rate. So hopefully that one we remember. Now N's the one we haven't seen before. We'll call that the number of terms. So the term number that we're actually trying to find. And Vn, what we're actually solving for, is the value after n years. So say n was 6, that means we'd be trying to find the 6th term in that sequence. Vn, in that case would be V6, would be the value of the 6th investment. It's kind of why we use V, it stands for value. So if we're finding the 6th year, n would be 6. Essentially what we're trying to do in this formula is calculate the value of the investment after 6 years. So that's what each one of our variables stands for within our equation. Let's do an example. What we say, let's go 6.2% per annum. Right, so let's write this out. Initial, pretty easy to see, is 1,000. Now D we still need to calculate, so let's calculate D, which is 6.2 over 100 times the initial investment. What's that? That's 62. Better double check that. Fantastic. Now we can write that in a recurrence relation. So Vn equals V0, 1,000, plus, we'll say 62n. So it's like writing it out in algebra, 62 times whatever term number it is we're trying to find. So let's say I want to find the fifth term. I'd write it out like this, V5 equals 1,000 plus 62 times 5. Amount of room there, so I won't be able to finish it, but hopefully you get the idea that it's much simpler when you do it this way. You can just substitute in any term number that you want and calculate it without having to find all the previous terms. So it's much, much more efficient than the original way that we've been going over. And this works the exact same for depreciation. So you'll be getting some scenarios of flat rate depreciation. I'm not going to write too many notes on that, or any, but it works the exact same way. Just with depreciation, we're decreasing in value. So make sure you're subtracting rather than adding when you're looking at depreciation. We'll just have a quick look at unit costs like we went over the other day. Right, so it works much the same. The formula we use yeah, it's basically the exact same as, oops, sorry, that should be a 0. It's the exact same really as simple interest. It's just, we're just subtracting, like with flat rate. It's just, we're going down. That's all it is. The only difference here is n isn't necessarily the number of terms. It will be how much that product is used, depending on the context of the question. Let's do an example. Alright, a computer is depreciated by 32 cents for every hour of use. It was originally worth $2,000. So what we're going to do is we're going to write out a recurrence relation to represent that. Alright, so V0, our initial value, pretty straightforward, 2,000. D in this case, alright, don't write 32 because that would be $32, 0.32. That's what it's going down by. With these ones, you don't have to do any calculations when you're actually writing out the recurrence relation. This one is just going to be Vn equals 2,000 initial minus 0.32 or D times n. With this, doesn't matter if n or d comes first, it's multiplication, doesn't change the order, but when we write it out like this, In algebra, we always write the number before the letter. So let's, for example, say I wanted to calculate the value of the computer after 100 hours of use. All right, so I'm not calculating Vn, I'm calculating V100. The value after the 100th term. So that would be what? All right, 2000 minus 0.32 times 100. $1,968. So it's much more efficient this way to work out terms that are further down the track, so to speak. That's about it for 5C. Again, like with any of these exercises, once you get into the more wordy parts, it gets trickier. Just make sure you're consulting the worked examples, and most importantly, keep asking your teachers for help. That's what we're here for. Do not suffer in silence. Keep asking for help. Thanks, guys.